Good morning, everyone. Uh, Today's session is about gyroscope. It is dynamics of mechanical system, practical number 2. And gyroscope is a spinning wheel or disc in which the axis of rotation is free to assume any orientation. Right? In this picture, you can see there is a red arrow. It will show the angular momentum, the direction of angular momentum, right? And here, because of the conservation of angular momentum, the gyroscope's orientation will not be changed by tilting the mounting, so that we can use gyroscopes to maintaining the orientations, right? This is the diagram of the experiment setup. In this practical, we are going to investigate the movements of gyro effect. Here you can see there are two different rotational axes. One is vertical, it is about B, and the other one is horizontal axis. Right, this is the apparatus where we are going to check the effect of gyro, and inside of this glass you can see the setup of gyroscope, and this is a rotating frame. It will rotate about vertical axis, and this is a gyro motor. It will rotate about that horizontal axis, and so there are two different axes of rotation, and you can see this is a weight which we are going to apply to check the gyro effect. We can change that distance, or that radius of that weight, right? We can change that so that we can change that angular momentum. So now it is 0, right? That radius or that distance is 0. Likewise, we can move that weight along that shaft, right? In here, this is precision weight to balance that gyro motor, right? This is an indicator. You can see it is whether it is horizontal or not, right? You can check from there. And by rotating precision mass with the help of that indicator, we can balance the gyroscope, right? To start the practical, we are going to adjust this radius. First one is 0.025 meter, that's mean 25 millimeter, the radius of that weight, right? So that first we have to make that radius as 25 millimeter. For that we have to move that weight along that shaft, and we have to measure that that radius or that distance should be 25 millimeters, right? In here we are using that vernier caliper. We can use vernier or any measuring instruments, right? Here after fixing that weight in 25 millimeter radius, we have to rotate that gyro motor and the rotating frame, and we have to get balance the gyroscope, right? For that, now we have to close that glass, and there are two different displays you can see, and two different speed controller. This is gyroscope, the rotating frame speed, right? For this practical, we are going to set 4 different frame speed, and then we have to find out the required gyro motor speed by balancing, right? So first we have to switch on this frame motor, then we have to give some speed. You can see now the gyroscope, that frame which have that gyroscope rotate at vertical axis, right? uh, that the rotational speed is around 10.2 rpm, and you can see that, but that gyro motor is not in horizontal position, right? It is not balanced. By looking that indicator you can see, right? It is not balanced, right? Therefore now we have to start that gyro motor, and we have to rotate this gyro motor about horizontal axis, right? Then by changing the speed of the gyro motor, we can balance the that gyroscope, right? That we will get balance, right? Now gyroscope is balanced, that the gyro motor is rotating at around 2200 rpm. So through the glass you can see, and by looking that indicator or that needle, you can see it is balanced now, right? The gyroscope is now in horizontal direction, right? So likewise we can we have to balance the gyro motor for four different frame speed, right? Now frame speed is around 10 rpm, right? Likewise we have to increase that frame speed, and we have to again balance the gyroscope. Then we have to likewise we have to get reading, right? Then we have to change the radius of the mass, right? Now it is 0.025 or 25 millimeter, right? Likewise we have to repeat the process, and after by using the data we can investigate the movements of the gyro effect, right? Now we will see how we are going to change the frame speed and take the respect balancing speed of that gyro motor, right? In the left side you can see this speed controller of the frame speed, right? Now it is 10.2 rpm. By rotating that speed control we can change the frame speed, right? For this frame speed the balancing gyro motor speed is around 2280 or something, right? Likewise for one distance or one radius we have to take four set of data, right? Then by using that we can investigate the gyro effect, right? And this is the observation sheet. In here you can see the first column is radius of the mass, the second one is momentum, right? Cylinder weight produce moment. Third one is speed of the gyro motor. Fourth column is speed frame. The fifth column is theoretical gyroscopic moment. It is calculated from a rotational speed of the frame. So the last column is indicating deviation between MW and the MK. And for your lab report submission you have to write down the introduction and the theory, and you have to plot the graph radius versus MW and radius versus MK in same sheet. Then you have to you have to compare the results. With that, you have to write down the answer for the discussion questions. So those three things you have to include in the lab report. Thank you.